The reflection property of parabolas give rise to a lot of interesting applications. For example, a satellite dish is shaped like a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point, where the receiver is located. If the dish is 10 feet across at its opening and 4 feet deep at its center, at what position should the receiver be placed? What I'm going to do to answer this question is draw a picture first so we can visualize what's going on. In this modeling situation, it's probably easiest to set up the parabola so that its vertex is at the origin. I choose to have the parabola open upward. It doesn't have to be that way, but that's what I picked, so you're going to have to live with it. I have that the parabola is 10 feet across, so from here to here is 10 feet. The vertex lies at the middle of the dish, so I know the x-coordinate of this point is 5. I also know that the depth of the satellite dish is 4 feet, so the y-coordinate of this point is 4. Now what we can do is find an equation for the parabola. Because it's a parabola that opens upward, we have that x squared equals 4ay. Now I have that x is 5, so 5 squared equals 4 times a times y is 4. So 25 equals 16a. Divide both sides by 16. I get that a is 25 over 16, which in a decimal is 1.5625. Now, remember, a represents the distance from the vertex to the focus. So, if I plot this point right here and call it the focus, I know that the focus is going to have to be 1.5625 feet above the vertex. For that reason, the receiver should be placed 1.5625 feet from the base of the parabola.